Welcome to the Daily Technology Pulse podcast by Daily Computers, your expert technology partners for public and private sector organizations throughout Maryland and Virginia. This episode is brought to you by Extreme Networks, protecting and evolving your organization's networks through extreme fabrics to reduce risk. And now your host, Rick from Daily.
Joining us today on the Technology Pulse podcast, we have Edwin Kohler. He is the Distinguished Principal Engineer at Extreme Networks. Edwin, how are you today?
I'm good, Rick. How about yourself?
I'm doing very well, thanks. We're here to talk today about fabric. And obviously not the fabric that I'm going to wear in layers as it starts getting colder. Obviously, when we're talking about fabric, we're talking about a fabric network. And, this is a topic that I had the pleasure of talking to some of your Extreme colleagues about before, but would certainly love to learn more about it. But before we do that, let's start with you. Tell us a little bit about what you do at Extreme, how long you've been there, what your responsibilities are.
I am a principal engineer within the CTO, within the Chief Technology Office. I'm primarily involved with security, so I'm dedicated to a security role. Internally, both with our IT teams, I work with our CIO, our CISO for extreme best practices and things of that nature. I also work with our product teams. I work with the CTO office to provide direction to rep some of the enhanced security features and directions of Extreme as a company within not only our products, but also within the holistic vision of what it means from Extreme, the overall strategic direction. I also happen to be one of the primary creators or contributors, at least, in one of the major features and functions of the fabric technology that we're going to talk about today. So my history with the fabric technology, and actually all of the fabrics that we're going to discuss here today, I've been involved with all of them.
The one thing I want to mention, because you talked about security, and there's one part of your background that I have noticed that I really wanted to bring up because I find it extraordinarily interesting. I see in your bio, it says you are a certified hacker. Now, explain what that means, because I think a lot of people are going to start having some really strange images at that.
No, nobody. As a matter of fact, anyone that's in the security industry and has any background would it's basically what's called a CEH, a Certified Ethical Hacker certification, and it's basically a white hat type of certification. It's really just a set of common practices, skills, tools, things of that nature, the ability to use them both for red teaming and for blue teaming, which means, attacking and protecting. And there are several certifications in that space. OWASP has certifications in the space as well. So it's basically a background of certifications that you need to have in the industry. That's all certified ethical hacking is at the end of the day. I'm a good guy. That's all.
Yes, no, and I had no doubt about that. But the interesting thing is, I think I come from a cybersecurity background, having worked in cybersecurity with the U.S. Department of Defense and the NSA. I think a lot of people don't realize that you need to have the skills to know how to defend against them. You need to have that background. And I love the fact that, the certification says certified ethical hacker, because obviously, we wouldn't want it any other way. But it really is about, it's not just putting yourself in the mindset, but it's utilizing the same tools and the same tactics that the non-ethical hackers are going to try to use to get at an organization's data.
Interestingly enough, one of my research focuses right now in that area is AI and ML, artificial intelligence and machine learning. But that's a whole other subject aside from fabric. So we're tandeming, but there are new dimensions to everything, and then there'll be some interesting things in store with Extreme Networks and how we handle and utilize both not only artificial intelligence, but also certain aspects of machine learning as well, which you always have to remember is really a subset of the overall AI environment.
And again, I understand, as you were explaining your role in helping to develop this technology. So this is obviously something very near and dear to your heart. So can you tell us, give us a little bit of an overview of the role that fabric plays in the SLED space today?
Let's talk about what that is first. When you look at it, there's obviously a need for security, for segmentation. Okay. Now, this need for segmentation actually goes back quite a long ways. It actually goes back to subscriber separation in the security space and in the provider space, the service provider domain. So really this need for subscriber separation, in other words, you as a customer prevented from seeing me as a customer within a provider, let's say AT&T or Verizon, whoever that may be, there was that need. And there was the need to create it at relative scale. That's really, when you look at it, that's what MPLS is all about. Now, the beauty of MPLS is the fact that it achieved segmentation at scale by the use of virtualization. Okay. And when you look at that sounds okay. Well, that seems straightforward. It's not, because when you look at other forms, you'd look at like VRF Lite or IPVPN Lite, things of that. Those are all ways that we do it. Notice how I'm using IP again and again and again in my dialogue here. We were kind of married to that mentality that's the way you did things over IP. MPLS is really no different. I mean, it all rode on top of IP. What MPLS introduced were several layers above the traditional model that did two things. First of all, establish control. Okay, so a control path to control the MPLS topology, and then secondarily a signaling plane. Excuse me. Okay, so you had a signaling plane. You brought about two concepts: a control plane and a signaling plane, and the separation of those planes from the data plane. Okay, the data plane being IP and Ethernet. Okay, and that's largely the way MPLS works. Signaling signals within the service, the labeling handles the data transport, and at the control plane perspective, i.e. MPLS labeling, and then the data moves at IP through the IP network in the context of the MPLS tunnels. So that's the way MPLS works. When you look at IP fabrics, it's largely the same thing, except it's just replaced by, signaling protocols, either BGP or a Lisp. In the case of like Cisco, they have to do things a little differently. But, they have this control plane, and then they have the signaling plane. Okay. Incidentally, I was involved in the development of these different technologies. So I'm not saying that one is better than the other or anything else. Okay. Just like when you look at it, a monkey is far superior to me in a forest. Okay. You put a monkey in a tree. I can make do in a forest and climbing trees, but monkey's far better than me. However, in an office environment, I'm far superior to the monkey, and the monkey at best is a pleasant distraction. At worst, can really be destructive. So, there's just that comparison. So it's not, it's fitting in the niches. Okay. So there's places for each technology. And the assumption that we can accomplish all of these goals without the need to bring in IP, either in the manner of utility, in other words, establishing the topology, i.e. IP routing like OSPF, okay, but also the service delivery, which is also IP, which is called IP forwarding through the IP routing, okay? So we kind of divorce ourselves from that context, okay? We're saying, okay, we're going to do this completely through Ethernet. And that's really what makes Extreme Fabric very unique. As a matter of fact, it's the most unique fabric in the industry because of that. And there's a lot of benefits from that, and we can talk about that as we move forward. But there are some obvious ones that stand out, first of all, is if I remove the need to deal with all those underlays and complexities of the IP routing and everything else, and I could deliver a fabric that's purely Ethernet based, one that is minimal touch. As a matter of fact, in the instances of the core switches, zero touch. Well, I obviously have a higher resiliency, a higher uptime, a much lower OpEx. So implementers, customers who already have extreme networks have shown that they've seen 11 times OpEx benefit. And that's fun. And this is customer testimonial. These customers have moved to the fabric for a number of base reasons. Number one, typically is the need to approach the segmentation. Everyone knows it has to be done. Traditional architectures, it's not an effective method. It's
Right.
not. So something like a state and local government, something like K through 12, with any of those customers, their primary role is not networking. They're educators. They're defense. They are law enforcement, government. Whatever the case may be, that's their primary role. Networking should be an enabler. That's exactly what it should be, and it should be nothing else. But it should not be overhead. It should not demand a high X, and obviously, it should have an optimized CapEx profile as well. In other words, it should deliver optimal service density and capacity capabilities, i.e., for the price point that they're buying. Okay.
Mm-hmm.
In other words, getting MPLS level capabilities and service capabilities for the price point of Ethernet switching. That's really what Extreme Fabric does. Okay.
Right.
And it provides it in the context of that too. It actually, when you look at it, I'm going to give you a quote from one of our we talked about Concord Hospital. We also have a very, very large healthcare network. And they have made statements that they have purchased a number of hospitals. Okay, they're large and they have expanded their footprint, so forth, so on. And I've been told by their IT staff that they've been able to shrink their acquisition time on the order of 5 times.
Right, and that was something that I really wanted to talk about, because you've talked about how this can be beneficial, obviously, to a number of different sectors, like you said, state government, local government. I mean, I'm thinking transportation is one of the big ones where, again, you definitely need that segmentation. So we've talked about the applicability, and we're talking about 5-time reduction, 11-time increase. So we've got some really solid numbers there. But when it comes to making the switch, you're talking about implementing this solution, because to a lot of organizations, making that change can seem very daunting. All of your infrastructure is going into your network, and then so how is it going to be? Is it going to plug and play? Is it going to be, well, now we have to, you talked about physical security, and that's a big thing these days, where you want that physical security, those devices, those cameras and those sensors, everything needs to be functioning at high levels. So it's obviously a situation where they're not going to have to replace a lot of their existing infrastructure if they wanted to implement the Extreme Fabric solution, right?
So you mentioned a lot of devices up there, IoT, things of that nature. All of these components and devices ideally should be separated. Best practices from NIST, CERT, any of these CISA, any of these type of organizations, they're going to recommend that each of these are segmentized, categorized, normalized, monitored, look for anomalies, so forth, so on. That's all in what I call my best 10 practices for zero trust. And I also have a separate package that I do for IoT, ICS, and OT, those technologies. It's important to realize that in order to do that, though, and do it at scale, you need to have the right kind of architecture in order to achieve it. Now, we talked about the fabric, okay? We talked about the fact of what it achieves. And because it's so different, you're right. A lot of people say, whoa, wait a minute, how do I, how does this, And again, I want to emphasize that what we do within the core, these ICIDs and all of this intelligence and this automation, the ability to learn services across, all through this dialogue of the control and signaling. Now, the beauty of that looks daunting. You're thinking, oh my God, at the edge of the cloud, remember, we present only IEEE standard interfaces. So if we expose a single routed port, it looks like a routed port. If we expose a VLAN, it's a VLAN. If we expose a subnet, it's a subnet. That's the beauty of making IP virtualized, is all of that becomes a service phenomenon at the edge of the network. And it's like the fabric now becomes a black hole, okay, in the context of IP, because you could be sitting in Japan and I could be sitting here in upstate New York, and we could be communicating across the fabric on a single ICID, let's say a layer 2 VSN, okay, which is a layer 2, a VLAN on my side, a VLAN on your side, connected through an ICID. You could be in Japan and I could be here, okay, if we had a global fabric. And we do have some customers that have global fabrics, okay? Mm-hmm. Let's say we wanted to do video services, okay? So we do video services and we would start a video surveillance camera. And now a video surveillance camera, most optimally, would use multicast, okay? And this is what we find with, by the way, some of our highest end video surveillance customers, ironically, are not airports, international airports, although there are a lot of video surveillance cameras in airports, believe me. You can attest to that as you walk through one.
Right.
But there's a vertical where you have a higher density, and that's casinos.
Did not think about that, but that makes a lot of sense, because
yes,
I mean, they've got to watch everything, because the methods of cheating these days.
There are cameras under the bar. There are cameras under tables. There are cameras above at multiple dimensions. Pan-tilt zoom, 8 megapixel. Some really phenomenal resolution that you can get in these environments. But all of that translates to bandwidth, okay? So obviously you're not going to move that in discrete streams. You're going to run multicast for these cameras, okay? So they need to have cameras multicasting. So now you say, okay, well, I try it with PIM. I try it with, it breaks. It's very, very, very limited what you can do in that type of context. Fabric is designed for that. When you look at it, another little flip that we did is we have source identification within everything within the fabric, particularly at the edge. So when a multicast source is generated, we identify the source at the outset. So it's tagged with the source. That solves the primary difficulty in multicast as a behavior. We solve it out of the gate. Okay. And best part about it is it does it constrained within the service that I want. So if I have a certain group, let's say video surveillance in my security organization, and I only want them to see that multicast, the fabric will limit that scope. And that's a beautiful thing now, because now I can drive multiple multicast environments. So we have like a casino. They're running multicast for their IP television services up to their guest rooms. They're running multicast for the gaming floors, the random number generators, and several other functions within the floor. They're running multicast for the video surveillance environment. And all of these are service separated. We go to a hospital context and they have, obviously medical telemetry and different services that are wireless of nature, including Vocera, which is used for the nurse alert and red alert systems, red, green, blue alerts, things of that nature. Right. Within the pink alert. Pink alert means baby's been lost, I guess. At least that's what I believe it means. But anyways, these alerts basically happen, and they have these little well, obviously they're moving all over the place, these doctors and nurses, so forth, so on. So, very dynamic environments that need to be very, very highly segmented. This is where fabric is beautiful. And it does it with very, very low OpEx environment. So we move from there, that one end of the spectrum. And then when you start to implement the fabric, at the very middle, you get the OpEx benefits, okay? And you get the fact that you can do things a lot quicker. You can do things a lot nimbler. Let's move on to really what happens from a security context now, okay? Because the separation is really what's key here. Well, remember, let's go back to the point that everything that's happening within the fabric is layer 2. When I'm talking to you and you're in Japan and I'm here in upstate New York, there could be dozens of switches between us in a fabric, okay?
Right.
That's invisible. It's a single hop from an IP perspective, which means now think about what that does to someone looking to scan the network, to gain a knowledge of the topology. It becomes black.
It's a blank canvas. It's not giving
It's a blank canvas.
It's not giving that perspective.
You cannot enumerate it. You can't tell how many switches exist. The only thing you can see is your service point termination, and you could enumerate where I would allow you to see within your service on the fabric, but everything else, black.
We talk about the efficiency. We talk about the effectiveness. I have to think that it's also a matter of it's allowed to be used as a singular network, correct? It's not where other technologies would require sort of a web of networks. This can be utilized as a singular point, correct?
That's correct. Because when you look at it from an air gap perspective, let's say I have 3 air gap networks, okay? And you say, okay, well, now I'm going to run OSPF. Okay. Well, now I've got to run 3 times the OSPF environment, and you basically have 3 times the OpEx environment because you're running 3 separate IP routed networks. Okay. When you look at it, you say, okay, well, if we condense things down and virtualize, such as, multi-topology stuff, like IPVPN Lite and stuff like that, you're still managing those 3 multiple networks, but you no longer have the air gap because now you got a singular network. You see where I'm going here?
Yes.
So in that legacy, you kind of have this catch-22. You either have a high CapEx and total separation, and then the corresponding high OpEx, or you lose the total separation, you go with the virtualized separation, and you still have the high OpEx, okay? So it's really kind of like you're gambling with the devil. You're not going to win, okay? So, it's just which evil's better. We kind of changed the equation with the Ethernet fabric, though, because that whole question goes away. Because now the separation is absolute, and we've proven it dozens and dozens of times. By the way, here's another additional note. Let's go back to MPLS. You got a bunch of people with, keyboards, and they're provisioning out things and doing services, and you want to change, you call Verizon they'll make a change, and so forth, so on. That obviously doesn't work in the context of a day-to-day business, right? It really doesn't. So that's really, when you look at it, that's where universal zero trust network access comes in. When we look at universal zero trust network access, you have this dynamic control at the access layer within the fabric, and that assigns you your ISID. That assigns any access control lists I may want to have assigned to you, so forth, so on. That actually drives all of the ISID behaviors within the core of the network. So now, when we put a fabric switch in, we no longer have technicians going in and typing consoles, and saying, okay, I'm going to assign VLAN 10 to port 16 and port 32, and I got to tag VLAN 10 on the trunk going out. All of that goes away. All of it goes away because the technicians never touch anything anymore. When the fabric comes up, it becomes what I refer to as a golden config. And that golden config is, what are my neighbor adjacencies within the fabric, my neighboring adjacencies for my nodes, and where is my management segment? That's it. That's all it has. When you look at it from a security standpoint, that's ideal. Everything else is driven. So really, when we look at it, when we look at zero trust network access, it provides all of these service plane behaviors. Okay. So think about it. You come into the network, and I'm actually going to go through a step-by-step mechanic of how this happens, okay? So let's say Caitlin and I are on the fabric, okay, and we're already there, okay. So she's part of it, I'm part of it, and we're part of the same ISID. Let's say it's ISID 1500. So Caitlin and I are members. Now suddenly you plug into the network, okay, and what happens then is you are then put into basically a private E-tree environment. And what happens is there's only one place you go, and that's up to Universal Zero Trust Network access.
Mm-hmm.
So now you go up and you're forwarded to the Universal Zero Trust Network access. It challenges you through, let's say, EAP-NEAP. Okay, so we use EAP-NEAP. We identify you, you verify your machine with a certificate. We say, okay, great, no problem. Rick is Rick. Okay, maybe you pass MFA. There may be various challenges, each depending on the enterprise and
right.
what they want to do. At that point in time, once you're validated, it says, okay, well, Rick is part of the organization that Caitlin and Ed belong to, the group, quote unquote. So we're going to assign him to ISID 1500. Okay. Now remember, you're in Japan. Okay. Caitlin's in Texas, and I'm in upstate New York. Now suddenly the fabric says, oh, Rick has got to be part of ISID 1500. Boom. That ISID is automatically assigned. It's extended right out to the edge. Assigned to you. Okay.
Mm-hmm.
So now what happens is you become part of that community of interest. Okay. Once you disconnect, that ISID is retracted. The service phenomenon at the edge that was Rick is no longer there. The VLAN that was there to service you is no longer there. And by the way, when we bring fabric to the edge, there's never a VLAN value. It's always VLAN value 0. The ISID goes right to the edge with fabric to the edge. So now that ISID just gets retracted. That's the ultimate in security when you think about it. There's never an exposed service edge. Gone are the days of forgotten VLANs in the wiring closets. You see what happens from a security context? And all of it happening with a lower OpEx profile. There are really very few technologies. As a matter of fact, this is really the only one that does that when you think about it, giving you a stronger security posture with a lower operational expense model.
And again, as you said, this is not new technology. This is something that has been around for a while, but it's a matter of working it and reworking it and improving it. And so it's really an evolutionary process of refining and making the fabric better for different types of organizations, whether again it's public sector, whether it's private sector, anybody who's in need of this type of we're talking about the segmentation, we're talking about the zero trust, and we're talking about zero touch, which absolutely is imperative to a lot of organizations these days because they don't have the overhead. They don't have an IT department. A lot of these organizations don't have an IT department of dozens of people, like, some larger private sector organizations. You're talking about a handful of people, if not, just a few that are tasked with all of this. So, it's really good that Extreme has been working to really evolve, and it's almost revolutionizing this technology that's been around for 11 years or so. Well, standardized for 11 years. It's been around for longer than that.
Yes, absolutely. And this is an important thing, is that it's one piece in the overall architecture of what Extreme does. We have wireless, we have several other aspects of technology being complement to what Fabric does. But Fabric provides really, when you look at it, the underlying engine that provides the automation. Okay, and that's key, because if you can get that piece done, then what you see is gradually a building on top of that foundation. You get that foundation through a simplified architecture. That's what Extreme Fabric does. Okay, so when you see us extend out into SD-WAN space and out into, secure access, secure edge type of approach, well, those type of approaches require that services separation, require that guarantee of path behavior end to end across the network, that value of services automation, all of that driven by a higher level entity, which would be your management space, the platform space. Universal Zero Trust Network Access. Gone are the days where you need, again, a high OpEx, where you have a lot of people touching CLIs and touching core routers, edge switches. A number of vulnerabilities happen that can be avoided. The ability to create outages within the routes, the ability to, create errors at the configuration edge, and then worse yet, vulnerabilities that may lay in the access layer that are unknown. All of those become eliminated because now we get, again, to that notion of the golden config, the driving of a policy-based construct to manage the fabric behaviors, and then more importantly, the ability to manage it cohesively. Once you give that to an organization, now what you have is the ability for anything, from a K through 12 school district who may have one or two people managing their IT staff, all the way up to a state and local government, which may have a more significant base. But I want to actually name a customer in this space. It's the Nevada Department of Transportation. The whole state of Nevada is managed by 4 people. 4 people.
4 people for an entire state.
That's phenomenal. So, they attest to it. You talk to Concord Hospital. They say it's the best decision their IT organization ever made. That's a big statement. That's a really big statement for a customer to make, that we are the best decision they've ever made. And,
that is.
And, there's a couple things about this. Is that I obviously work for Extreme, but I help create this technology. And one of the big things is the benefit it's bringing to mankind. The benefit it's bringing to the support infrastructures, critical services, things that are critical for human safety, public safety, things that are critical for, our children, in their education. All of this, kind of makes me feel warm underneath. It makes me feel proud. And I think that's an important thing to it as well, is that human dimension to the technology that's really important. And I just want to, before we close, I want to, emphasize this. This is one of the reasons why I'm with Extreme Networks. I think it's a great company to work with. I think it's a very human company that puts the technology in a very human focus. State and local governments, the ability to have agencies move and communicate more efficiently, particularly like now in the Southeast with the situation with some of the, the emergencies that we have in that space, the ability to deliver communications and the ability to get system uptime, either maintain that system uptime throughout the critical hazard, or the ability to bring up systems again in response to the disaster in a very quick uptime afterwards. That's really some of the developments that you've seen around us as of late, is this zero-touch fabric, the ability to just plug the switches in, get them power, they will discover themselves, they will create the fabric. Anything you've driven from a policy standpoint within Zero Trust Network Access is automatically inherited down into that fabric, and your uptime is in minutes.
These really are the reasons why DALY is so proud to partner with an organization like Extreme Networks, because we're always touting to our customers that we want to provide solutions rather than just products. And when you think about the fabric and you think about everything that you're talking about, the security, the reliability, the gains, the savings, that really becomes a solution. It's no longer just viewed as, like you said, a necessary evil that we have to spend money on. It's something that is truly going to enhance an organization.
Exactly. It's a beautiful thing, and we're not done with it yet. We're going to add artificial intelligence to the equation.
We're going to save that for another conversation, but we're going to have that conversation. Ed, thanks so much for joining us today. We've really enjoyed having you on the podcast. Appreciate everything that you shared. And again, anybody who wants to learn more about the Extreme Fabric, just contact your DALY representative. Reach out to us here at the marketing team. we'll be happy to put you in touch with Extreme and discuss how this can really help you. Ed, thanks so much for being on the Technology Pulse.
And that wraps up another insightful episode of the Daily Technology Pulse podcast. We hope you enjoyed this episode. Before we sign off, we want to take a moment to remind you of some important legal considerations. The views and opinions expressed by guests on the Daily Technology Pulse podcast are their own and do not necessarily reflect the views or opinions of Daily Computers or its partners. The content provided in this podcast is for informational purposes only and should not be considered as professional advice. No part of this podcast may be reproduced, distributed, or transmitted in any form or by any means without the prior written permission of Daily Computers Inc. If you have any comments, questions, or suggestions, please feel free to reach out to us. You can find us at www.daly.com. The Daily Technology Pulse podcast will be back with more exciting discussions on the latest in technology. Until next time, stay curious and stay connected.